Hi everybody, and welcome to another session with Mrs. John. So this lesson is actually because of a request to go through question 1 of your DC explanation assignment. Your DC explanation assignment is on page 7 in your booklets, and question 1 is to do with internal resistance. Question 2 is to do with Kirchhoff's laws, and the request was to go through question 1. So I've just written it out on the board so you can actually see what I'm talking about, but I'll just read through the beginning of the question. In the diagram, the battery has an internal resistance R, so that's your battery. And the first question is, explain why the terminal voltage V of the battery is less than the EMF of 50 volts. So when a circuit is connected and there's a current flowing, what happens is every coulomb of charge that enters the battery gains 50 joules of energy. But however, because the battery is made up of chemicals, these chemicals have a resistance and they use up some of the energy. Now, because they use up some of the energy, not all of it is available to the outside circuit. Now, the physics way of saying it is the energy of each coulomb of charge before this is going to be less, is going to be greater than after they leave. So there is what we call a potential drop or a voltage drop across the internal resistance. It simply means the internal resistance has used up some of the energy, so not all of it is available to the outside circuit. So that's what this means. Now, the next thing what happens is this is a variable resistor and the resistance is increased. So if this resistance is increased, how is it going to affect the current drawn from the battery? So if you increase the resistance, the overall resistance increases, and because current is inversely proportional to resistance, if the overall resistance increases, then the current drawn from the battery is going to decrease. So that's your answer to B. And then if the current drawn from the battery is going to decrease, how is it going to affect the terminal voltage or the voltage available to the external circuit? Now, if the current drawn from the battery is going to decrease, it's going to use up less energy there, right? Okay, so there's a smaller potential drop across the internal resistance. So there's a greater voltage available to the external circuit because it's the total coulomb of charge that the total amount of energy each coulomb of charge gets is 50 joules per coulomb. So not so much is lost over there, so there's more available to the outside. And then R2 is now disconnected, leaving R1 by itself. So the circuit looks like this. What will happen to the voltage across R1? So the moment you remove a parallel branch, you've actually increased the resistance because adding resistors in parallel decreases the total resistance. So if the resistance has increased, then the current is going to get smaller. And the question was, what's going to happen to the voltage across R1? So it's a smaller voltage. So it's going to be, so the voltage, so it's a smaller current, so a smaller potential drop over there, so a larger voltage across R1. Okay? And then it says, as the battery starts to get older and starts to run down, its internal resistance increases. Now the question E is, explain how the terminal voltage of the rundown battery relates to the EMF of the battery when just the voltmeter is connected to its terminals. So this question really means this bit is not there. So it's just the battery and you've taken some wire and just connected the voltmeter across. So how does this value, which is stated on the battery itself, compare to what the voltmeter reads? They're going to read the same thing because the cell is not really supplying its energy to anything, and so there's no current flowing in the cell. Okay, so that's the answer to E. And question F is, if you have two similar circuits and that is, it's supplying a load, so there is something on the outside. What can you say about the terminal voltage in two scenarios? One when the battery is old, one when the battery is new. Okay, and they both claim to have the same EMF. So if the battery is old, the internal resistance is going to be really high, so not much, so the terminal voltage is going to be low. Okay, so it's just a low voltage for the external circuit. However, if your battery is new, then the internal resistance is small, so the terminal voltage is going to be high. And so that's the answer to this first question. And I hope that helped. Bye for now.